invertible function. Are you able to hear me?
Yes, sir.
Okay. I asked you to solve 26th problem. Once it is over, try the next one, guys. I have to explain you the proof, right? So listen, for theorem 1, this, is there any doubt from 26? I hope everybody got the answer. Right, it's simple only, no? Okay. So theorem number 1, this states something like this. Function f is mapped from x to y. The codomain of f is the domain of g, and the codomain of g is the domain of h. Okay. Are functions, then prove that h circle g circle f is equal to h circle g circle f. So what is h circle g circle f? So h circle g circle f is, so this is going to be the expression h of g of f of x for all values of x. Where do they come from? For all values of x that comes from the set x, because where does this x come from? First function is domain of x, that is in x. Similarly, h circle g circle f of x is going to be how much? H of g of f of x for all values of x in capital X. Okay, so they both are the same only. That is what they're trying to say. Actually, there is not needed, just for you to understand. That's it. Okay, because the last problem itself has told you. So did anyone check the codomain and domain in the last problem and then start doing the problem? Or you just like that followed it? So if you see in the previous problem, what are they saying? F is a function mapped from natural number to natural number. So codomain of first function is the domain of the second function. Similarly, codomain of the second function is the domain of the third function. If you look at the codomain of the third function, it is R. If at all you wanted a fourth function, FGHI, for example, then that function should have started with domain R. Okay. So this one I'll do it later. Okay. Let's do some problems that are first based on invertible functions, then I'll come to theorem 2. So let's start some exercise problems. So listen to this. First, f is a function mapped from 134 to 125 and g is a function mapped from 125 to 13. Be given as f is equal to 1, 2, 3, 5 and 4, 1 and g is equal to 1, 3, 2, 3 and 5, 1. Write down G circle F. So how to write? So when they say write G circle F, write G of F of X. Okay. What are the values of X that you can substitute? 1, 3, 4. So G of F of 1 is what they are asking. G of F of 2 is what they are asking. And G of F of 3 is what they are asking. Right? This is equal to G of, what is F of 1, guys? 2. F of 1 is 2. Look at the ordered pairs. So when you give the input 1 for the function, output comes as 2. So G of F of 1 is G of 2. But what is G of 2? 3. Is everyone clear? So G of 2 is 3. Similarly, G of F of 2 is how much? G of, what is F of 2? Oh, 3 is, okay, sorry. 135, 134. Now it is right now. G of F of 3 is how much? G of 5. But what is G of 5? 1. G of F of 4. F of 4 is G of 1 upper. But G of 1 is, I hope this is clear. Right? Please copy it. Yeah, you have to. When they say write G circle F, you need to write for all the values in the domain of function F. What is the domain is? Then you need not write. It will become an infinite set. You'll write some values and leave. They'll not ask like that. Okay. So the proof one, we will do it again. So let's go with easy ones first. So third, find G circle F and F circle G if f of x is equal to mod x and g of x is equal to mod of 5x minus 2. Solve it. Can you rub this? See, those who are online, I hope you're also trying. Right? Are you guys trying or not? So find G circle F and F circle G if f of x is equal to mod x. So what is G circle F, guys? So mod of 5. 5 mod x minus 2. Correct? Up f of g of x. Mod of modulus of 5x minus 2. So 5x minus 2 within a modulus itself is a positive value. So mod of mod is mod itself. When first one itself is giving you a positive value, you don't need a second modulus. That is what I meant. Next one, f of x is equal to x cube, 8x cube, g of x is equal to x power 1 by 3. Got it? Finished. So what is g circle f? So g circle f is 2x. So g of f of x is equal to 8x cube the whole power 1 by 3, that is 2x, correct. F of g of x is 8x cube to the power of 1 by 3, correct? So it is 8x. Fourth one. So this is a good problem. If f is a function mapped from where to where? So they have not given it, but will you be able to find? For all real numbers, which is not equal to 2 by 3 to codomain, you need to find that range. We don't know what is the value. Okay. So find, show that f circle f of x is equal to x. Can you do that? So can you do that? F of x. 4 into, in the place of x, you will substitute 4x plus 3 divided by 6x minus 4 plus, you already have a 3 divided by 6 into 4x plus 3 by 6x minus 4 minus 2. So how much will this be? 16x plus 12 plus 18x minus 12 divided by 24x plus 18 minus 24x plus 16. 24x gone. 12 are gone. 18 plus 16 is 34x divided by 34. Cancel it. You will get the value of x. Okay. So what is the definition of invertible function? Tell us. If you have a function, so let's recollect. If you have a function f map from x to y, and you have another function g map from y to x, okay, then if g circle f of x comes out to be x, for all values of x that comes from where? That belongs to capital X. Similarly, f circle g of x is equal to x for all values of x that belongs to y. That is iy. Correct? If this is the case, what can you say about this? Can I say f is the inverse of g? In the second case, g is the inverse of f. So look at this problem. F circle f of x is coming out to be x. So what is the inverse of this function? Inverse of the function is the function itself. Because you're doing what? F circle f of x. So f of x is giving you an exponent. The function is an inverse of itself. That is the meaning. Okay, if at all you want to find how it is so you're still not convinced, okay, then what you can do is, you know the steps for proving onto function and finding the range. What is it? So what is the question of 4x? Assume this to be y. Then what are we supposed to do? 4x plus 3 is equal to 6xy minus okay. What is it? Is equal to 6x right? But I want x in terms of y, no? X into 6y minus 4. So x will be equal to 4y plus 3 divided by 6y minus 4. So if I call this as g of y, for example, if I call this as g of y, then what is g of x guys? But what is this? It is a question itself. That is why in this problem we told f is the inverse of x. Okay, so once you come to this step, what are we supposed to do? G of y is equal to 6y minus 4 divided, sorry, 4y plus 3 divided by 6y minus 4. Okay, when that is the case, for all values of y that belongs to real number, except that is to 6 upon 2 or 4 by 6. 4 by 6. For all real values except 2 by 3, there is always a pre-image associated with this function. So f is a function mapped from r minus 2 by 3 to r minus 2 by 3. Then g is also a function which is mapped from r minus 2 by 3 to r minus 2 by 3. That is the reason why this function is able to be an inverse of itself. Because for inverse to happen, inverse to appear, what should happen? The codomain and domain should get interchanged. Whereas in this case, fortunately, what is happening? They both are same. Are you able to understand to some extent? Yes. So if you need not do all those steps, since you can say f circle f of x is equal to x, the given function is an inverse of itself. So what will you write the inverse as? The question itself. That's it. Frida, is there anyone having confusion? So try the next one. But before that, those who are online, is there any? Did you understand the previous problem?
Yes, sir.
Amshri, Harini, and Arvind.
Yes, sir.
Okay. Now listen. Can you try the fifth one? State with reason whether the following functions have inverse. First one has inverse. Sir. Yeah. It's many to one function. It's not a one-to-one function. So it is not bijective, hence it does not have. No. What about the second one? 5, 4, 6, 3, 7, 4, 8, 2. No. What about third one? 2, 7, 3, 9, 4, 11, 5, 13. So is it? So if you observe the number of elements in set A and set B are the same, then what is happening? It is a one-to-one function and onto function. Yes, because it is a bijective function. So bijective functions have inverse existing for them. Sixth one. They have given some hint also. Try this. Show that the function f mapped from -1 to 1. So domain is restricted. Function is mapped from -1 to 1 to real number given by f of x is equal to x divided by x plus 2 is 1 to 1. Can you do that? 1 minute time. Do it fast. For some value of x1 comma x2 that belongs to -1 to 1. For some value of x that belongs to -1 to 1, what will happen? F of x1 is equal to f of x2. So you will have x1 divided by x1 plus 2 is equal to x2 divided by x2 plus 2. So x1, x2 plus 2x1 is equal to x1, x2 plus 2x2. x1, x2, x1, x2 gone. 2x1 is equal to x2, x1 is equal to x2. Correct? Find the inverse of the function. But here, what is happening? Observe this problem. Initially, what did they give? For you to prove that it is a one-to-one function, they gave the codomain as a real number. But for you, when they are asking you to find the inverse, they are restricting it the domain. So they call it as range of f. Means the range of f might have been real numbers or not. So we don't know. So first, our job is to find what that particular range is. So how do we proceed? Same steps. So what is the question, guys? F is mapped from -1 to 1 to the range of f. So what is the question? F is equal to how much, sir? X divided by x plus 2. Okay, we'll assume this to be y. So x is equal to xy plus 2y, which implies x into 1 minus y is equal to 2y. So x is equal to 2y divided by 1 minus y. So, no, correct only. X into 1 minus y is 2y. Okay, 2y divided by 1. So y belongs to R except y belongs to R except 1. So, unfortunately, what is happening? The function is 1-to-1 in the real number system, but it is not on to in the case of real number system. So R minus 1 is required. So for that to happen, what should be the inverse? So the range is R minus 1. Any doubt in this? Okay. Now listen to this carefully. How to find the inverse? The inverse is already in front of your eyes. X is equal to 2y divided by 1 minus y. No. So this, if I call it as g of y, then what is g of x? 2x divided by 1 minus x. Then find f of g of x and tell me what is the value. Coming over. You're getting it. Similarly, what is g of f of x be? That is also x. So what can you conclude? G is the, so you will get this as x. I hope everybody got it, right? So from this, can I conclude that g is the inverse of f, right? Then what is the value of f inverse? Inverse 2x by 1 minus. So in the process of finding range, you will get x in terms of y. No, that y whatever you are getting, replace y with x. That will be the inverse. Just to show that this is the inverse, you will do an extra step of proving that f of g of x is equal to x. That's it. But that should happen for a particular range. F of g of x is equal to x only when the range is restricted to r minus 1. Had this not been given, you cannot prove it. It will not have an inverse. Why? Because it will not be an onto function. You have to understand. So that is why you need to be concentrating on the domain and the range. In this given domain and range, yes, this function has an inverse. Right? Nitish, Frida. Yeah. So next problem, can you guys do it on your own? Consider the function f map from R to R given by f of x is equal to 4x plus 3. Show that f is invertible, find the inverse of f. So when they say show is f is invertible, what will you do? In your textbook, they would have done f of g of x is equal to x, g of f of x is equal to x. That is one way, or you can do it as a bijective function. That is easy. All bijective functions will have inverse. What are you getting? Okay. See, listen. Did you get this? F of x1 is equal to f of x2. 4x1 plus 3 is equal to 4x2 plus 3. Okay. X1 is equal to x2. I hope this you got. For onto function, what will you do? Y is equal to 4x plus 3. Then x will be equal to y minus 3 divided by 4. Now, what are you supposed to do? The inverse onto what are you supposed to do? Now, you will stop with this. No. You will check for all values of y that belongs to this codomain. For all values of y that belongs to R, is there going to be a real number x that is going to appear? Yes. So for all values of y that belongs to R, there exists what? A pre-image in set capital X. In the real number set. Okay. Hence it is a one-to-one function and onto function. So you can say it is invertible. Now we need to find the inverse. For that, what you will do? This you will call it as g of y. So from the same steps that we follow for onto function, is there anyone having confusion in this? Because we are following three different same method for three different properties. What is it? Onto function, range, and inverse. You guys have clarity of what you're supposed to do. So onto function, what you do is you don't write it as g of y. You will see whether for all values of y there exists a pre-image. If it exists, it's onto. If not, leave it. It's not onto. Okay. Then range, what you will do, you will find you have written no y belongs to R. That is a range. Okay, so here codomain is equal to range. That is the reason why it is onto. Whereas for finding the inverse, x is equal to y minus 3 divided by 4, then you will assume it to be g of y. Then what is g of x? X minus 3 divided by 4. This will generally be the inverse. If you want, you can find g of f of x or f of g of x. So when you find g of f of x, what will you get? G of f of x now. 4x plus 3 minus 3 divided by 4. Cancel x for all values of x that belongs to this real number. Any doubt? Clear? Hence, since you are getting g of f of x to be x, what can you conclude? G is the inverse of f or f is the inverse of g. Okay. So what will be the answer? X minus 3 divided by 4. That is the inverse. That is the inverse. Eighth one. Consider a function map from R plus. See, this is a confusion, okay? Generally, in some books, R plus represents all positive numbers. In some books, R plus means 0 is also included. That is actually a universal confusion existing. It's not a mistake of us. So here, what is the give? R plus is the set of all non-negative real numbers. So when they say non-negative, some books consider 0, some books don't consider 0. So, okay. Map from R plus to 4 to infinity. F of x is equal to x square plus 4. That is a given function. Show that f is invertible. Do it fast. Project. So for one-to-one function, you will get only plus x will take because R plus 1. What about onto? X will be but so y is equal to x square plus 4. X square is equal to y minus 4, which implies x is equal to generally what do we tend to do? Plus or minus y minus 4. But what is the value of x? Where is x coming from? R plus or 4 to infinity? Is it coming from R plus or 4 to infinity? Where does this x come from? R plus x right? So since it is coming from R plus, you will not take the negative value. You will write it as root of y minus 4. Now, what is the least value of y that you can substitute? So the least value of y that you can substitute is 4. And the highest value that you can substitute is infinity because y minus 4 should be greater than or equal to 0, which implies y is greater than or equal to 4. Answer will be from 4 to. So that is why they gave you this codomain. So codomain is equal to range, hence it is an onto function. Okay. Then what will be the inverse of it? By looking at the step, you will get the answer. What is the inverse? X is equal to root of y minus 4. Oh, you have to show that that is the inverse. That's it. Root of y minus 4. That's it. So generally we write inverse in terms of x. Adanala I say root of x minus 4. But I hope you understood. No, it has come here itself. Can you try the next one? That's it. That is one way of, see, there are two ways to prove that the function is invertible. You take the function, find the, you take g of x and you have f of x, find f of g of x. If it comes out to be x, that is one way of proving invertible. Or the second way is you prove that it is one-to-one and on. So I'm going with the first method, one-to-one and on. So in the process of onto itself, you will get the inverse. Yeah, do it. So f is a function map from r plus 2 phi to minus phi to infinity. F of x is equal to 9x square plus 6x minus 5. So one-to-one, how will you solve? For quadratic, I have already shown you the steps. I think I did a problem, right? Minus b and 7. For one-to-one. For one-to-one, what will you do? 9x1 square. x1 comma x2. Consider the elements x1 comma x2 that belongs to r plus 1. Okay. Then 9x1 square plus 6x1 minus 5 is equal to 9x2 square plus 6x2 minus 5. Minus 5 are gone. So 9 into x1 minus x2 into x1 plus x2 plus 6 into x1 minus x2 is equal to 0. Correct? So what can I take out? I can take out 3 into x1 minus x2 outside, and what am I left out with inside? 3 into x1 plus x2 plus 2 is equal to 0. Now observe, where does x1 and x2 come from? Positive real numbers. So positive real numbers means this is sum of all positive numbers, which can never be 0. So from this, I can conclude that x1 minus x2 is a 0. From this, we can say x1 is equal to x2. So what did we prove? That it is a one-to-one function. Okay. Then what about onto? This you have to use the discriminant, the quadratic equation formula. Minus b plus or minus root of b square minus 4. 5 minus y over the minus 5 minus y over. So minus will come out, 5 plus y is 6. Done. Uh, 9x square plus 6x minus 5 minus y is equal to 0. Correct? Huh? So x is equal to minus b plus or minus root of b square minus 4 into a into c by 18. Correct? Huh? So minus 6 plus or minus root of, if I take 36 outside, it is 6 into y plus 6 or y plus 6 divided by 18. சரியா? Minus 6, or else I'll write minus 1 minus, sorry, plus or minus root of y plus 6 divided by 3. Is it clear? Now see, for every value of y that I substitute here, what is the least value of y that we can substitute? According to the question, the least value of y that you can substitute is minus 5. Okay. So if you substituted, what actually speaking, listen, logically tell me, y plus 6 can be greater than or equal to 0. Y is greater than or equal to minus 6. But if you put minus 6 here, what will you get? You will get minus 1 by 3. What is this actually? This is x is equal to minus 1 by 3. So when you substitute minus 6, you are getting minus 1 by 3. But minus 1 by 3 is not a part of r plus x, etc. So for us to find the values of y which belongs to r plus, what is the least value that you can substitute? Minus 5. That is why they restricted the codomain. It is a restriction. Okay, they created a restriction on the codomain so that the vice versa is existing. Now the question is, if I need to get a positive value of x always, I need to ensure that either of the values is positive and greater than the other. If you observe, I have minus 1 plus or minus root of y plus 6. Should I choose minus 1 minus root of y plus 6 by 3 or minus 1 plus root of y plus 6 by 3? I'll choose this one because when you substitute minus 5, what is the least value you are getting? You will get 0. So according to textbook, what is R plus? Non-negative real numbers, 0 is also included according to this text. We'll follow in that because we get the question. But some books say that all non-negative real numbers means 0 is not included. Are you guys able to understand what I'm trying to say? So what is the inverse of this? So root of y plus 6 minus 1 by 3 as the inverse. That is what they asked us to do. சரியா? Okay. This kind of F circle, G circle, will do it after you master this inverse function. Okay. Shall we try this problem? 11th one. So f is a function mapped from 1 to 3 to ABC, and it is given like this: f of 1 is A, f of 2 is B, f of 3 is C. Find f inverse. F is a function mapped from 1 to 3 to ABC, given by f of 1 is A, f of 2 is B, and f of 3 is C. Find f inverse. You have to tell me. Is it bilateral? Find f inverse. I think you need to know what is f, right? So what is f equal to? F is equal to 1 comma A, 2 comma B, 3 comma C. Well, then what will f inverse be? What were we discussing? F of 1 is A, F inverse another. A comma 1, B comma 2, and 3 comma sequential. Then what will be the domain and codomain of F inverse? F inverse will be mapped from ABC to 1 to 3. That's simple. Huh? Then what is F inverse of inverse? That is F itself. Again, you reverse the ordered pair and write it. That's going to give you the answer. Okay. So as I told you, prove that problem. We'll do it later because we'll master F inverse. So do the 13th one and 14th one. So f is a function mapped from R to R given by f of x is equal to so f is a function mapped from R to R. F of x is equal to 3 minus x cube, the whole power 1 by 3. Find f of x. What do you think will be the answer? Well, I don't write it. So are you able to understand?
Yes, sir.
3 minus in the place of x and substitute panna. 3 minus x cube the whole power 1 by 3.
The whole cube.
The whole cube.
The whole power.
So this and this will get cancelled. 3 and 3 are gone. Minus of minus x cube is plus x cube. X cube to the power 1 by 3 is x. So what can you conclude from this? F is the inverse of itself. So what about the 14th one? Oh, sorry, I wrote it. Is there anyone who's copying it? Done. F is a function mapped from real numbers minus 4 by 3 to real numbers. Okay. Be a function as f of x is equal to 4x divided by 3x plus 4. Then find the inverse of, the inverse of f is the map G, that is range of f to R minus 4 by 3 is given by quarter. So simple, y is equal to 4x divided by 3x plus 4. So 3xy plus 4y is equal to 4x. So x into 3y minus 4 is equal to minus 4y. So x will be equal to minus 4y divided by 3y minus 4, or this is also equal to 4y divided by 4 minus 3y.
4 by 5.
Option B, yeah. That's it. Okay. So I hope these problems you are clear, right? So shall we see the remaining ones? So this one we didn't see, no? Did we see 28 now? No, let's do it fast now. S is equal to 1 to 3. Determine whether the function mapped from S to S defined below has inverse. So f is equal to 1, 1, 2, 2, 3, 3. It is 1 to 1 and on 2. So yes, it is bijective. 1, 2, 2, 1, 3, 1. Many to 1. 1, 3, 3, 2, 2, 1. It is bijective. Right. And you need to find the inverse of it. So what is f inverse in this case? 1, 1, 2, 2, and 3, 3. In the case of last one, f inverse is equal to 3, 1, 2, 3, 1, 2. That's it. So shall we try this? 27. F is a function mapped from 1 to 3 to ABC, and G is a function mapped from ABC to apple, ball, cat. Okay, defined by f of 1 is A, f of 2 is B, f of 3 is C, G of A is apple, G of B is ball, and G of C is cat. Okay, show that F, G, and G circle F are invertible. So what is F? 1A, 2B, 3C, 1 to 1 and on to. G is a function A apple, B ball, C cat. It is bijective. G circle F. So G of F of 1, G of F of 2, G of F of 3. So G of F of 1 is G of A. So G of A is apple. Otherwise, this one will be cat. That's it. So all these three are invertible. Find F inverse. Is this thing you can do it. A1, B2, C3. அதே மாதிரி G inverse is apple A, ball B, cat C. G circle F வந்து apple 1, ball 2, cat 3. All that's it. No? And find F circle G also. So they're asking find the inverse of inverse of G circle F that we found. What is it? Apple 1, ball 2, cat 3. Okay. They're asking us to find F inverse circle G inverse. So F inverse another A1, B2, C3. Yeah. F is mapped from 1, 2, 3 to ABC. Up F inverse again. F inverse will be from ABC to 1, 2, 3. Accepted? Okay, wow. If is the case now, F inverse is this. What is G inverse, guys? Apple A, ball B, cat C. Okay. What is G inverse of F inverse? Oh, F inverse of G inverse. Upper F inverse of G inverse of what should I start with? Apple. Then F inverse of G inverse of ball and F inverse of G inverse of cat. What is F inverse of G inverse of apple? 1. F inverse of G inverse of cat? 2, 3. So here also we got apple 1, ball 2, 3. So both the sides they are same. Hence that is the answer. Hence they both are equal. So apple 1, ball 2, cat 3. Adhe mari apple 1, ball 2, cat 3. Clear? So having said this, there is a theorem that is there where we can prove that G circle F inverse is equal to F inverse of G inverse. Sub reverse. What is happening? G circle F inverse is not equal to G inverse circle F inverse. Rather, what is it equal to? F inverse circle G inverse. So that's what we need to prove. From the basics of invertible functions, we can try it out. Shall we try it? So F is a function mapped from X to Y. G is a function mapped from Y to Z. Be two invertible functions. Can they be invertible? Yes. Then G circle F is also invertible if G circle F inverse is equal to F inverse circle G inverse. How to solve this? So let's see what are the proof they have given us. Okay. So just a minute. What is the first step, guys? So to show that G circle F is invertible with G circle F inverse is equal to F inverse circle G circle, it is enough to prove that F inverse circle G inverse of G circle F is equal to I of X. Okay. So, If this G circle F is called as capital F, this is capital F inverse, and F inverse circle G inverse, I call it as capital G. If F inverse is equal to capital G, what will you prove? F circle G is equal to X. If you prove that, is it not enough? So that's what they are saying. So F circle now, that is F inverse circle G inverse of G circle F. If you are able to prove that this is equal to Ix and the vice versa, what is it? G circle F of X is circle F inverse of G inverse. If this is equal to Iz, then it is more than sufficient. So this is what they are saying. And these are the steps that are given. See, I'll stop with it because I want you to work on inverse of it. First the theorem la mind lo then you will understand. Till there, is there any doubt till what we discussed? So independently you can do, if an inverse problem is asked, you can do. If an onto based problem is asked, you can do. Range you can do. You can solve all these things. Right? Actually, the chapter is over, but maybe in the next class we will discuss few more problems and then we'll go to the next one. So clear. So try. Since the problems in textbook are over, again I need to give you an assignment. This time I'll give you a consolidated assignment of the whole chapter, except binary operations. Binary operations is not a part of this syllabus. That is fourth exercise. If at all they include that point, I teach. Generally, it is not there for the past 4 years. I'm not doing it. Okay. Yeah, I'll give you an assignment. Try it out and come. Next class, if time permits, we'll discuss the assignment and go to the next chapter, or we'll discuss the questions from the assignment itself. Next chapter is very simple. Once you understand this inverse trigonometry is nothing. Okay, one point I want you to do is revise your trigonometric functions. Trigonometric functions, I'll tell you what you need to remember is the domain and range of all functions, all trigonometric functions. For example, domain of sin x is what? That is range. Domain of sin x is all real numbers. Other domain of cos x is all real numbers. But the range is between -1 to 1. So these things alone revise. So the things will be easy in the inverse trigonometric. Yeah. So that's it. There are no other doubts, we can wind up. Those who are online, any doubts? Amsini, Harini, Shubham, Arvind.
No, sir.
Okay. So then can we wind up?
Yes, sir.
Okay. Okay. Okay.